Namaste. Namaste. Myself Vidyapeeth from the Faculty of Physiotherapy and Diagnostic Interdisciplinary Radiology. Today we are going to discuss on the session interaction of radiation with matter. That is an important topic for this at the second semester. So let's discuss about the interaction of radiation with matter. When an X-ray or gamma ray beam passes through a medium or any matter, interaction occurs between the beam and the matter. Initially, the electrons are ejected from the atoms of the absorbing medium, which is in turn transferred their energy by producing ionization or excitation of the atoms along their paths. So, the electrons are ejected from the atom of the absorbing medium, which is transfer their energy, producing ionization and excitation of the atom along their path. So, when any radiation interact with the material or medium, it ejects electrons that produce ionization and excitation in their paths. If the absorbing medium consists of a body tissue, so interaction of radiation with matter when X-ray or gamma ray beam passes through a medium, interaction occurs between the beam and the matter. Initially, the electrons are ejected from the atom of the absorbing medium, which in turn transfer their energy by producing ionization and excitation of the atom along their paths. If the absorbing medium consists of body tissue, sufficient energy may be deposited within the cell. So, after interacting with the atom, electron passes the energy and deposits the energy in the body tissue or cells, destroying the reproductive capacity. However, most of the absorbed energy is converted into heat, producing the biological effect. So, attenuation. When monochromatic radiation passes through any material, a reduction in the intensity of the beam occurs. This is known as attenuation. Attenuation means absorption and scattering. There are two processes that is covered in the attenuation. Attenuation occurs exponentially. A given fraction of the photon is removed from a given thickness of the attenuating material. Okay, let me discuss about the HPL, the thickness of the absorber material required to decrease the intensity of a non-energetic photon beam. Means the energy of the photon beam is seen to half its original value. This shows the quality of the penetrating power of the X-ray. Attenuation of a photon beam by an absorbing material is caused by 5 major types of interaction. First one is the photodisintegration, second is the coherent scattering, third one is photoelectric effect, Compton effect, pair protection effect. So, coherent scattering, elastic scattering, Thomson scattering, these are the scatterings that is involved in the coherent scattering. X-rays cause the bound electron to vibrate. These in turn emit radiation of the same frequency in all directions. So radiation is a wave nature. Attenuation without absorption, the energy is scattered in all directions, but none of the energy is absorbed. Compton effect. Elastic scattering modified incoherent. An incident photon interacts with an orbital electron to produce a recoil electron and a scattered photon of energy less than incident photon. The photon collides with the electron and hand over the part of its energy to it, means transfer some part of energy to the collide electron. Angle through which the photon is scattered, the energy handed over to the electron and energy lost by the photon interconnected. So the Compton effect results in both attenuation and absorption. The attenuation caused here is dependent upon the electron density and is partially seen for all substances except hydrogenous material like water and substance. Where the Compton effect is greater, it doesn't depend on atomic number. It is measured as mass scattering of photoelectric effect. The photoelectric effect is a phenomenon in which a photon interacts with an atom and ejects one of the orbital electrons from the atom. The photon transfers all its energy to the atom. All its energy to the atom. This is used to overcome the binding energy as well as to provide a kinetic energy to the photoelectron. The ionized atom regain electric neutrality by rearrangement of the other orbital electron. The electron that undergo these rearrangement surrenders some of the energy in the form of photon known as the characteristic radiation of the atom. Means if a photon interacts with the atomic electron of inner cell, then it gives sufficient energy to the inner cell electron and emit and eject it from the atom, and the other electron from the outer shell comes in the inner cell to fill the vacancy. The difference between the two binding energy of two cells are imaged as characteristic radiation. So absorption of these characteristics radiation emerged internally in the atom may result in emission of auger electron or secondary electron. These electrons are monoenergetic in nature. The mass photoelectric attenuation coefficient is directly proportional to the cube of the atomic number and inversely proportional to the cube of the radiation energy. Z3 by EQ. As a graph on the right, absorption is correspond to the binding energy of the electron in different shell. In diagnostic radiology, the primary mode of interaction is photoelectric. It is also responsible for the contrast effect. In therapeutic radiology, low energy beam in ortho voltage irradiation caused excessive absorption of the energy of one. Pair protection. Pair protection is the other second effect that produced when a photon interacts with the radiation interacts with the metal. Pair protection. When the photon with energy in excess of 1.02 MeV passes close to the nucleus of an atom, the photon disappears and a positron and an electron appear of equal energy 0.51 MeV. Annihilation. These two particles collide, converting two photons with equal energy of 511 keV. Thus, the energy absorbed from the beam with incident energy is given by E absorbed. Pair protection results from an interaction with the electromagnetic field of the nucleus, and as such, the probability of process increases rapidly with atomic number Z2. So the pair protection is directly proportional to Z square. In addition, the likelihood interaction increases as the photon energy increases. So it is directly proportional to the photon energy. mass absorption coefficient are typically identified for most biological materials. In this energy range, the absorption per gram is maximum for hydrogen because of its higher electron density. Particular radiation particulate radiation can be classified into two categories: ionizing or charged particle like electron and proton. Uncharged particle. The two different modes of interaction and energy transfer of electron with matter include: first, we have the collision between the particle and the electron cloud resulting in ionization and excitation. This is called collisional loss. Second one is collision between the nucleus and the particle resulting in Brownian radiation. This is called radiative loss. So there is a two type of loss: collisional loss and radiative losses. Interaction of radiation with matter. So the first effect is photoelectric effect. In the photoelectric effect, a photon of energy h nu collides with an atom and eject one of the bound electron from the K, L, M or N cell. The eject electron is called a photoelectron and it has an energy equal to the h nu, that is energy of photon minus binding energy of electron. So the incident photon is totally absorbed. The atom is left in an excited state and emit characteristic radiation and augur electron or secondary electron while returning to ground state. Means in the photoelectric process, photon interact with the electron of the K, L, M or N cell. The ejected electron is called a photoelectron and has the energy equal to the h nu minus binding energy of the electron of the cell. Okay. The photoelectric effect involves bound electrons. The probability of ejection is maximum. Probability of ejection is maximum. The photoelectric effect involves bound electrons. The probability of ejection is maximum. Probability of ejection is maximum if the photon has just enough energy to knock the electron from the shell. The tighter an electron is bounded in the orbit, the more likely is to involve in a photoelectric reaction. Tightly bounded electrons are mostly available in K shell, and hence most photoelectric interaction occur in K shell. At the K shell, the absorption of the photon increases because the K shell electron is tightly bound with the nucleus. So the photoelectric effect is mostly occur in the K shell, and hence most photoelectric interaction occur in the K shell. The absorption of the photon increases markedly as the X-ray photon energy is increased uh, is increased from below to above the binding energy of K cell. This is known as Ka-age effect, Ka-age absorption. So in this session we had discussed about the photoelectric effect and other effect that are produced or that occur when radiation interact with the photon. Okay, like photoelectric effect, Compton effect, pair production effect, coherent effect, and annihilation. So these are the effects that is produced after radiation interaction with matter. I think you are satisfied with this session. If you have any queries, put it into the comment box. Thank you.